My name is Chris Santiago. Can you guys hear me okay? All right. I am a solutions engineering manager for a company called Unravel Data. Unravel, quick background, we do application performance management for your big data applications. So we've worked with some of the biggest clusters, with some of the biggest customers in the world. And today, what my talk is going to be is taking in those on-prem workloads. So say, for example, you might be using Hadoop with some of your Spark workloads. You know, what's the best way that we can do to manage and move these workloads up into the cloud? So, you know, at first, today, I'm not sure how many of you guys are running your workloads in traditional, like Hadoop environments today, but it's messy, right? I mean, you've got operations folks that are managing these clusters. They're managing expectations with the application folks. You know, you've got application. I'm sure there's a lot of application developers here in the room today. You know, how many times were you, you know, talking to your system admins saying like, "Hey, what's going on with that cluster?" So on and so forth. On the application side, you know, there's a lot of issues where maybe it wasn't the operation side. Maybe it was something to do with the application itself, whether that be bugs in the code, so on and so forth. You know, in an on-prem environment today, you do have the option of adding more nodes, right? So, but there's a cost associated with that, right? So, you know, hardware, software. There's also dependency on hiring Hadoop experts, right? So, very, very cost prohibitive if you're trying to do this from an on-prem environment. So, what's the next best thing we can do? Let's talk about the cloud. So, Azure, as you guys know, great option, right? One of the biggest things that you get from cloud-native stack like Azure is you got the infrastructure managed by Microsoft, right? So let's abstract away dealing with the hardware and software costs, and we can have Microsoft manage that, right? Elastic computing, right? So I'm sure you guys do a lot of data science workloads. So if you guys are, you know, you might not need all the power of your cluster. So why don't we go ahead and do some sort of like on-demand computing? Another big one here is separation of storage and compute. So in your traditional Hadoop environments, when you wanted to go ahead and add more storage, you know, you also had to add that compute component. And now we can go ahead and separate that. And finally, as we move to the cloud, and now we start really leveraging cloud-native technologies, why don't we actually have purpose-built clusters based on the workloads that we're trying to run, right? So if I have my data science workloads, and I might be sharing it with like my batch jobs, why don't we just have separate clusters so that way we don't have to deal with that multi-tenancy, right? But how do we choose this, right? So there are a plethora of Microsoft technologies out there, right? So whether there would be sticking with IaaS, so just spinning up just regular VMs, we could use some of the cloud-native solutions that are out there today. So whether that be Databricks, whether that be running Spark on HD Insight, or maybe you might be doing a hybrid cloud situation, right? And really trying to choose which technology is best it's really a best guess, right? So I've worked with a number of customers, small and large clusters, trying to figuring out how they do this. And a lot of times it's really they go through with their, you know, their SI of choice and they try to figure out, you know, what's the best combination and size, and it's really kind of a best guess, right? So if we choose, today it's you know, it's kind of a best guess, trying to figure out exactly what Azure stack we should be using, right? But what if there was a better way? What if we had the ability to use the data, or capturing the data that you guys are actually using today, and actually have a more data-driven approach in terms of which technologies we should use? So let's use Unravel, right? So again, Unravel's application performance management tool. We do have some features and capabilities where we will have the ability to first understand your cluster, right? So right now what you're seeing here is a dashboard which shows, we'll connect into your on-premise environment today. And we'll look at things such as, here are the nodes that you're using today. Down to the application level, these are the types of applications that we're running. The users, if you're using queues, et cetera, and so forth. If we go down to the node level, we can see, you know, how our CPU, our memory resources are being consumed over time. We've got this nice little heat map, so this is very useful for identifying bursty workloads. So we really understand, and we're really looking at it at a very granular level, looking at down to the application level to really understand what's going on here. And that's what this report shows here. And now let's talk about some of the scenarios that we can do. So today, with Microsoft, you've got HD Insights. You can do Databricks. You can do lots of different technologies that are out there. So what if we gave you the ability to go ahead and slice and dice this for you, right? So this run schedule report here. This is my screenshot here. So you can see this is selected as HD Insight, and then you could select your region. And so everything that you would normally select from within the Azure portal itself, and shows the different types of VMs. For some customers, they might have some custom agreements with Microsoft, and so they can go ahead and put that selection over there. But yeah, so HD Insight, whether that be Databricks, you can go ahead and put those scenarios in here. You go ahead and run that report, and you get this output here. So we've got two types of scenarios in this report that you're looking at right now, cloud mapping for host. So lift and shift is going to be looking at it from a cluster-wide perspective. What is this going to cost if I go ahead and actually just do lift and shift of the entire cluster, right? So based on our selection here, we can go ahead and show, this is a summary up here at the top, so we can see which instance types that we should be using. And then it breaks it down into what those instance types would be doing, right? So this would be the simplest lift and shift model if I wanted to have that quick and easy way of doing this, and I don't want to affect some of my data science workloads, and I just want to get it into the cloud. And a lot of customers want to do that, right? Because they just want to get into the cloud first and then figure out what they want to do afterwards. This next tab here is cost reduction. And so what we're going to do is, because we know how your applications are actually used, this is going to actually be based on the way that you're actually using your data, or how you're processing your data today. We're going to actually give you something that's a little bit more aligned to what that actual usage is, right? So we can see here we've got a different instance type here. Same thing down here, we give you that information over here. But if we looked at previously, this was $170-ish for lift and shift. Cost reduction, we brought that down to $17.86. So now we're starting to look into a little bit more cost-saving measures, and now we can be a little bit more finely tuned in the clusters that we'll launch for whatever for my clusters today. So everything that we've been talking about so far has been cluster specific, but I'm sure, especially when you were working with your data applications, there's lots of different tenants, right? I mean, you could be, your ETL team might be you might be using resources on your cluster. The data science might be using resources. So what if we can go ahead and create, have some slice and dice capabilities? And so this workload fit here is going to address that use case exactly that way. So on the left-hand side here, you've got the ability to select, again, very similar on the reports on saying which application type queues, for example. In this particular case, I went ahead and select the finance department. So let's just say my finance department, everybody else is going to stay on-prem, but maybe I want to go ahead and move these guys. Maybe they're actually doing some data science workloads. Give me some scenarios as to what technology I should use and what that's going to actually cost me. So I go ahead in here and I go ahead and select my finance workloads here. You got that nice heat map here to kind of give you kind of exactly how that usage is being done over time. So really easy to read this. The red is the mostly used. You've got the white is least used. So this seems a little bursty in nature. So once you actually start kind of mixing and matching and trying to figure out, now we're talking about purpose-built clusters, right? Once I define what that slice may be, let's actually go through some parameters here, right? So I go ahead and say, very similar to that previous screen, right? In my example here, maybe my finance department is doing a lot of Spark workloads, right? So let's go ahead and actually select AWS Databricks, right? Select the region that they would be in. They can go ahead and select the VM types. Again, you have the same custom cost. And so now, once I actually go ahead and put that in, I apologize, it's a little blurry here, but I can go and start looking at things in terms of if I were to look at my Databricks cluster and I wanted to actually hit 100% of my SLAs. It's a little blurry here, so I'm looking at about $129, right, for that particular workload. And then I can also see what those the same instance types that I should go ahead and pick. So instead of guessing which instance types I should use. This is actually based on actual usage. We can go ahead and give you that recommendation from there. For some people, maybe I don't want to hit 100% of my SLAs. Maybe 95%, 90%, in this case, 80%. I want to be able to, maybe this is something that's a little more exploratory. I know that they're bursty, but I don't necessarily care about missing or about hitting my SLAs. I can go ahead and select this option, and now this down here, you can see what my node type should be for my drivers and workers. But I mean, if you look at the cost savings here, $129 if you want to hit my SLAs versus $22. Now we're talking about some savings there as well. Also, kind of talking about that, when we were looking at that heat map, we noticed that there was a lot of peaks, right? And so in this particular workload, if we wanted to further use some of the cloud-native technologies that we have in terms of like autoscaling, we can actually go ahead and simulate, hey, if we were to set up autoscaling for this particular workload, we can actually take that cost of $129. We'd save about 47% if we were to follow, kind of this autoscaling timeline, and we can actually take that even further from $129 down to $67, right? So again, possibilities are endless here. So especially when you're, for the folks that are responsible for trying to figure out, hey, what is the best technology I should be using? You now have some data-driven insights into, hey, is this the right fit? What's the cost? And then ultimately, driving you to into the instances that you should use. So one more example I have for you guys is we've been talking about how we're able to help migrate things to the cloud. We also do have, right out of the box, regardless if this is a Databricks environment, if this is like an HD Insight, one of the core things that we do right out of the gate is application performance management, right? And so here's a very simple Spark application, and you get this out of the box, right? So being able to look at a Spark application, like on the right-hand side here, this is a good example of showing, like, if I were looking at all my executors, this is my VM RSS metric, so I can actually see how much resources were being consumed over time. So this is very good to kind of understand, did I set my executors right, so on and so forth. On the left-hand side here, similar to what you guys see from Spark UI, but we've got a nice little distribution chart here. So now we're down to the task level. So if I want to understand maybe like data skew, this can kind of show me what that distribution is, right? So here I could see 6 tasks taking about like 4 to 5 minutes, and then I got some that are taking 4. And so this becomes a very valuable tool for data scientists to really try to, if they're looking for optimization and performance, this is a very good way of understanding how it broke down so I can identify things like data skew. And then finally, we've got a recommendations engine, which a lot of data scientists love, because if they're trying to figure out, hey, how can I make this, what partition should I set? The size of my partitions, the number of executors, so on and so forth. We do have some intelligence built in where we're not only going to provide you some crisp recommendations on the application level on what you'd want to set for that application, but then we also provide, I like to call this like an automatic root cause analysis, right? Some of the things that we notice that either A is going to justify some of the recommendations that we've shown here, but B, if there are things like, for example, like data skew, which isn't necessarily something that you would actually solve with configurations, and we'll actually point it out here and say, you may want to look at this particular stage. This is where we're seeing some massive data skew. So all in all, with everything that you saw from the cluster level down to the application and being able to provide that application efficiency, we hope that we're able to help guide you into which solutions that you should use for in the Azure environment. So thanks, guys. Any questions? Geez. Yes.
So a quick question.
Yeah.
You do this only for the Spark clusters?
So we'll work with Spark. You're talking about like HD Insight with Spark. We do Databricks. Which ones did you have in mind?
I was thinking of more of a heterogeneous environment, like Oracle migration recommendation.
Oh, not today.
Okay.
Yeah, sorry.
Test. Okay, so in the first slide where you talked about a cost reduction, the 129 versus the 17,
Yeah.
was that purely based on VM spec change, or was there something else in there?
Yeah, so that would be purely VM spec change.
VM spec change.
Yeah. So I mean, as you know, I mean, you could have a lot of applications that might be, compute heavy or memory heavy, and so we take that into consideration, and that's where you'll see some of the variations in terms of what the costs are. But that would ultimately be driven from the VM cost.
Okay, so you have a VM optimizer. You also have an auto-scaling optimizer.
Mm-hmm.
Do you also take into account any time performance improvements that you will see between open source Spark that you're most likely running on your Hadoop on-prem versus using something like the Databricks
The
runtime?
Databricks?
Yes.
Yeah, so that's where the recommendations engine will come into play.
Okay.
And we're actually partnering with you guys, so we'd love to have a sidebar with you. But we're actively partnering with some other customers with you guys. So
Awesome. Thank you very much.
Yeah, no problem.
What's your cost model and engagement model to take you into my customers?
So my sales guy's not here. I'm more on the sales. I'm on the more on the tech side. I can give you my card and we can talk more specifically.
Yeah,
but generally,
offline, yeah.
we do have a pay-as-you-go model. So if you are running in Databricks, we would kind of mimic whatever whatever subscription you have there. But I'd have to tie you in with my sales folks.
So how does this compare to what you get out of the box with Azure or something like App Insights?
Good question. So you're talking about how we compare
Or
between...
just what the kind of insights you get from this versus what
Yeah,
you get out
great
of the box
question.
with Azure?
So our App Insights is going to be... how do I describe this? Let me talk about from what we do. So our recommendations are going to be very application specific. So that would be if let's say, for example, we're talking Spark. So that'll be talking about maybe what Spark executor size we might be, what we might want. Maybe even down to the partition level. We might even look at places to look for caching, right? So a lot of customers might use us for kind of QA, UAT gating, just making sure, hey, if I'm being flagged because I'm not caching my RDDs correctly, so on and so forth. So those are going to be the application. Those are going to be the recommendations that you're going to see. I'm not super familiar with App Insights, but I think that's going to be more on the kind of infrastructure itself. Yes.
Follow-up question, do you expose this data through APIs or anything to say you wanted to put it into Power BI?
100%. Yep. And we do have a lot of customers that will. The question was, do we integrate that, expose it out to additional APIs? And yes, we do. Everything that you see on the screen is accessible via API. Mm-hmm. I'm sorry?
Do you have alerts?
Yes, we do. That's we have auto alerts, all this stuff. We've got a lot of proactive alerting, and we'd love to have that additional conversation with you. Sure.
Yes. How does the Autoscale save the cost? In which way it is efficient? Can you please describe?
Sure. So the auto costing that I showed here in the demo is right now. This is phase one. So it's kind of showing you this is what the potential would be. There's still a dependency for the customer to actually do that, but where it's very useful is especially for a Microsoft where they're trying to show that hey, this isn't going to cost you 2 or 3 times more if you move it on-prem. I mean in the cloud. We want to be able to show that this would actually be actual savings if we were to follow this model with this particular time, so on and so forth. So I mean, the information is available via API, but we're not actually doing it for you.
Okay.
Yep, no problem. Hmm? Sure.
I got 2 questions. One, you may have to redirect me later. Which
Yes.
is, are you guys on G Cloud?
In Google?
No, as in the government procurement for public sector.
Sorry, that was a bad word to say here.
You could be. It's no problem.
I'm not sure. No, we're not.
That's
It's-
okay. The second question is, what about you said of on-prem Spark Hadoop systems to Azure or to the cloud?
Yep.
So what about which kind of on-prem? I mean, how do you take care of the versioning and all that stuff? So, for example, I'm running HTTP or a version of Cloudera or
Yes. Great
vanilla
question.
vanilla Hadoop cluster.
Yes. Yes.
How do you deal with that?
Yeah, so our bread and butter has been, where we started was supporting all of those flavors of Hadoop. So, so to answer your question, that doesn't matter to us. Where it would matter is if it's very old, like if it was a couple years old, but that is independent of which Hadoop flavors. So we have all of the flavors, and Hadoop. Vanilla Hadoop, MapR, Cloudera, Hortonworks. And we've worked with all of these guys in coming up with their initiative for their cloud migration strategies.
So will the applications, so if the on-prem version is running a bit older version of Spark, less than 2 years, less 2 point whatever,
Yeah.
and the target when you migrate to Databricks with the latest version of Spark,
Yep.
what happens to the code?
Great question. So I'll talk about it from the cloud migration side. So the cloud migration side is going to be just looking at performance metrics. So it's going to be kind of independent of the, whatever Spark version that you're at, right? So we're looking at saying how much did this Spark application take in terms of vCore, RAM, so on and so forth. So that's going to be the what we're going to take into account in terms of what we're going to recommend. When you move it up to the cloud, we'll have a Unravel specific APM for whatever that may be. So if that's Databricks, whatever version that is deployed, we'll be supporting that particular version itself.
Thank you. Super. Super.
Great. Well, thanks again, guys. Thanks for staying out late.